All right, so like I said, today we are taking what we learned last class, which was all the vocabulary of how angles are related to each other on parallel lines with a transversal, and we're going to apply it to proofs. When we did proofs back in the first unit of this class, we were giving reasons for different things. Now the reasons are going to be these vocabulary words. So let's just review a little bit of the vocabulary and prerequisites that we need to be able to do these sorts of proofs. The first thing is talking about parallel lines. We should know this already. Parallel lines are two lines that what? Do they intersect or do they not intersect? They do not intersect. They have the exact same slope. So when we were working with parallel slopes, we made sure we were using the same number. They do not intersect. That means they do not cross. One of the things that we kind of went over last time, and it was on your homework assignment, but enough people asked me about it that we needed to put it again on these notes. When I'm talking about arc marks, I'm talking about these little bitty arcs on angles. Now, they're not just there willy-nilly. If there are the same number of arcs on two particular angles, so for example, how many arcs are on this angle? No, this one right here. One arc. How many are on this one? Two. Those are not the same because they have different arc marks. But if you're putting the same number of arc marks, those little arches, on an angle, you're indicating that they are congruent, which means that they are the same. So like this one, see how they both have one arc mark? That means that they are congruent and they have the same angle measurement. Now that's going to be important for us when we start proving these different parallel lines. So if we look in the first little section here, this is our alternate interior angles converse rule. So this for us is blue. This is what we used last time for blue. So go ahead and put a little box around this blue, highlight it blue, whatever you're doing to do my color scheme, but it needs to be blue. If you notice, just like on our quiz trade cards, these angles are on the inside of the parallel lines and they're on alternate sides of the transversal. Because they are marked with one arc each, we are saying that angle 4 is congruent to angle 5. And if they're congruent based on those arc marks, our conclusion is that angle J is parallel to angle K. So we can use these vocabulary words and these concepts to prove parallel lines. Now that we see that 4 and 5, my alternate interior angles, are congruent, we can conclude that these two lines are parallel. So we put the little parallel mark on it. Our second set of vocabulary words are our alternate exterior angles converse. So that is my orange for those of you following my color scheme. For orange, we are saying that if the external alternating angles are marked with the same arc, meaning they both have one arc mark on it, we are proving, or we are saying that angle 1 is congruent to angle 8. And our conclusion is that the lines are parallel, J and K. Mark these in the correct color. So we're using the vocabulary to prove that the lines are parallel. Kind of backwards of what we did last time. That's why we're saying it's the converse. When we did logic, we were talking about that's where you flip the if and the then statement. Our consecutive interior angles is green, so grab your green marker or green highlighter. Consecutive interior. Consecutive is that big word that means same side. So if you'll notice, 3 and 5 are consecutive. Do these have that arc mark on them? No, because these are not congruent. If we remember, like it says right here, this means that they are supplementary. Supplementary means what? Equals 180 degrees. If we can show that they add together to equal 180 degrees, then we are proving that J is parallel to K. Okay, so the first two, we talked about them being congruent proves parallel. This green one, we're saying if we know they're supplementary, equal to 180, then we know that they're parallel. Our third vocabulary, we're back to seeing the arc marks on corresponding angles. Corresponding angles is my red. For corresponding angles, that means they're in the same spot and that they're congruent to each other. If we see that angle 2 is congruent to angle 6, then we are proving that J is parallel to K. So notice our conclusion every time here was that the lines are parallel. That's our goal today, is kind of prove that two lines are parallel using my vocabulary words backwards. Now, if you notice, there are some vocabulary words from last class that we did not use. Today, to prove parallel lines, we cannot use the conclusion that they're linear pairs or vertical angles. We might use those as an argument in our proof, but they cannot be our conclusion of our proof. They're not enough information to prove that two lines are parallel. These four are the ones that are enough information to prove that two lines are parallel. Okay, so let's write that down for ourselves. Proving two lines are parallel, we're going to make sure we remember that we do not use or do not prove with our linear pair, which was pink. Do I have a pink on here? There's my pink. And not vertical angles. Vertical angles were my yellow. Now, we're going to use those today at some point, but to conclude that lines are perpendicular, we're not using linear pair and we're not using vertical angles. We'll use the rest of them though. Okay, so if I present to you this set of angles, first thing we need to do to prove that two lines are parallel, we need to find a relationship between the angles. How are these two angles related? They're both on the line, but more specifically, I need one of the four vocabulary words from the top that we've highlighted today. How are these related?
Are they both on the inside? Yes, no, maybe so.
So they're not both on the inside. They're not both on the outside, but Kate got it. They're corresponding. That's my red. So take your red and we're going to highlight these arcs in red. Since they have one arc mark each, we are indicating that they are congruent. Because we can use corresponding angles to prove congruency, we will say yes. These two lines, M and N, are parallel because of the corresponding angles. Oops, spelled that wrong. Converse. So we can conclude again that M is parallel to N, since those angles that have the arc mark are congruent. One arc mark on each means they're congruent to each other. Using my vocabulary, how are these two angles related? I know someone had this on a quiz trade card when they look like this. They're vertical angles. Okay, let's highlight them as vertical angles. Is vertical angles enough information to prove that line M and N are parallel? This is going to be a no. Vertical angles is not enough information to prove parallel. So that's what we're going to write down. Vertical angles is not enough info to prove parallel. Now we can still use this later on in our proof arguments, but to just conclude that they're parallel, it is not enough information. Let's look at example 3. Since we're looking to prove that they're parallel, we try to figure out how these two congruent angles, one arc mark, are related. Alternate exterior. Exterior because they're on the outside of my parallel lines. Alternate because they're on alternating sides. My alternate exterior is my orange, so we're going to highlight this one in orange. Those arc marks are congruent, which means yes, we can prove they're parallel due to that alternate exterior angle converse. Now you're going to laugh Because if you look at number 4 on your paper, is anything there? LOL, it didn't print. So I want you to draw this image on your number 4, exactly how I have it. So you have 2 flat lines, M and N. Make sure you label them. You have your transversal R, and I want you to mark the 2 angles I've marked with 1 arc and then 2 arcs. I'll give you a second to copy that down. My bad. Okay, so what do we notice about the markings that I've made on the image? How many arc marks are on this one? And how many arc marks are on this one? Are those telling me it's congruent? No, they have different arc marks. Additionally, these 2 angles right here form a line. I know someone had that quiz trade card. What is it called when they form a straight line like that? Starts with an L. Linear pair. So a linear pair is not enough information to prove that 2 lines are parallel. It's still how they're related. They would add up to 180 because they're supplementary, but that's not enough information to prove that they're parallel. So we'd have to say no here. Again, the 4 that we have written in that first little box up there are the 4 that do allow us to conclude that things are parallel. If it's not one of those 4, we still have a relationship, but it's not going to prove to us that the 2 lines are parallel. Let's throw it back a little bit to kind of what we did last time. We did problems like this before. We're going to find the value of x that makes M parallel to N. Well, if we want these 2 lines, M and N, to be parallel, how does this angle need to relate to this one to make that happen? It would equal 180. Very good. So here's what I know. I know that these 2 angles right here are consecutive interior angles. They're inside the parallel lines on the same side of the transversal. So when M and M, when they marked consecutive interior angles, when those are what's called supplementary, by the way, what does supplementary mean again? Equal to 180 degrees. Very good. When they are adding up and equal to 180, then the 2 lines are parallel. So let's figure out what it would take for that to happen. If we know that these 2 angles, x and 2x, need to add up to 180, what kind of equation can I write for that? Let's set it up. I would take the first angle, you can't see it. I would take the first angle, which is x, and I would add it to the second angle, which is 2x. And that should be equal to how much? We just said it. 180. Now this is a simple equation to solve. If you're still needing the box method, you could totally use the box method here, but it's almost too simple to use the box method. So I'm going to show inverse operations on here. 1x and 2x I can add together for how many x's? 3 x's. So I have 3x equal to 180. What do I do with this 3 in front of the x to get it to go away so I can solve for x? I divide by 3. Therefore, x is equal to 180 divided by 3, and I hope you're trusting me that that's going to be equal to 60. So if we can prove that x is equal to 60, it makes those 2 angles supplementary, and we can use the consecutive interior angles converse to prove that the 2 lines are parallel. So all of this vocabulary comes swirling back a lot. We want to keep straight which ones are congruent and which ones are supplementary, which is why you have the little sheet from last time that has either an equal sign or an equals 180 next to it. Because notice, next to the green, it says equal 180, yeah? So we know that this should add up to equal 180. Let's try another one. We're still going to do it together because recognizing all of this stuff is kind of hard. In number 5, if we want these 2 lines to be parallel, we need to figure out if this relationship is strong enough to do that. What would you call these 2 angles right here? One of the 7 vocabulary words on your colored paper, or the 4 at the top, honestly.
It starts with a C.
They're corresponding. Very good. They're in the same location along the parallel lines and the transversal. First, just lost my whole train of thought. For corresponding angles, do we want them to be supplementary or congruent? Do we want them to be equal to each other or equal to 180? Congruent. We want them to be equal to each other. That's what's next to the red section on my coloring notebook and on the top of this paper, that they're congruent. They have the same arc mark. This setup for my equation is a little bit different. We're not going to add them up and make them equal 180 because that's for supplementary. What am I going to do with these 2 red values, these 2 red expressions? Yeah, Kate's saying, well, if they're congruent, then they both have to be equal to each other, no? Again, you can totally use the box method for this if that is your strength in solving equations, but I'm going to show inverse operations because it's a 2-step equation. The first thing I'm going to do is subtract 55 to both sides. I want to do that so the 8x becomes isolated. This is like the arrows step of box method, so we're still doing the same thing. Cross the line, change the sign, which is how this becomes 40. Similar to the step right above this, what's the last thing I have to do to isolate x? Divide by 8. 40 divided by 8 is 5. If you don't trust me, trust your calculator. So we know that these 2 angles will create a parallel system of lines if x is equal to 5. Because we know that those corresponding angles should be congruent or equal to each other. So we've noticed how important this vocabulary is. So I want to take another 5 minutes to do a little bit more quiz trading, because now that we've got the juices flowing, we should be a lot faster when we meet up with a partner for quiz trade. So I'm going to put 5 more minutes on my watch, and I want you to stand up with your vocabulary card, and we're going to do a little bit of quiz trade. Does anyone still need instructions on how to do that?
The vocabulary card is the one that we colored last time.
No, not the one you colored last time. Sorry, your pink quiz trade card. Whichever one you ended up with at the end of the last time we did this, I want you to start with that one. But same rules. Go find a partner, high five, ask your question, you quiz, you trade. Yes? 5 more minutes. Here we go. Oop, I didn't stop this. Yeah. Like I said earlier, we're going to use now this vocabulary that we just practiced again to start working on building proofs. Proofs are arguments for mathematical facts. They always start with a statement and then a reason, or some other words that mean statement and reason, but they're in these 2 columns. Here's a bit of information for you for today. Hi, put my pen down somewhere. There it is. When you're doing a 2-column proof, you're going to make sure you're starting by identifying either the linear pair, which is our pink vocabulary word, or the vertical angles, which is our yellow vocabulary word. Now, I told you earlier that those are not enough to prove that 2 lines are parallel. I'm sticking by that information, but we do need to use them in our proofs because they're really nice ways to relate angles to each other. Our final conclusion should always be something from the following list. This should be either alternate interior, alternate exterior, consecutive interior, or corresponding angles. Those are going to be our final conclusions to get us to our final statement, because those are the ones that prove parallel, and we're proving parallel today. So for most of these, I've given you an answer bank, so you'll be able to help me help you get to the correct statement or reason. In proof number 1, it says, given that angle 4 is congruent to angle 5. They have the same arc mark, so we're good. To start a proof, this is a nice review. What's the first reason you always use when you're starting a proof? What's the first reason? Oh my gosh. What's it called? Given. Very good. We should always make our first reason given, because that's what we're starting with in the problem. They literally told us that information, so it was given to us. Now we need to draw some conclusions. We want to start with either linear pair or vertical angles. So if I'm looking at angle 4, is there another angle that is either a linear pair or a vertical angle with angle 4? 1. And they are what kind of angles? They're vertical angles. So we'd say angle 1 is congruent to angle 4 because vertical angles. Vertical angles are congruent. And angle 1 and angle 4 are congruent to each other. So beep boop, they are vertical angles. Now my next reason, I'm telling you to use the transitive property of congruence. And if we think about the transitive property when we studied proofs the first time, that was the one where we could say if A then B, if B then C, therefore A then C. Basically it's the one where we can cut out the middleman. So if we look here, we have if 4 then 5, if 1 then 4. What angle am I using in both congruencies? 4. So I can cut it out, which means which two angles are going to be congruent to each other? 1 and 5. So we'd say angle 1 is congruent to angle 5 based on that transitive property where I could cut out the middleman. I used angle 4 in both congruences. I don't have to talk about it anymore. I just use 1 and 5. Now if you notice angle 1 and angle 5, how are angle 1 and angle 5 related? What is that called when they're like in the same spot? Corresponding. Very good. So corresponding angles is one of the conclusions I can use to finalize the idea that the two lines are parallel. So we have finished this proof. We have proved that line G is parallel to line H. So again, if we notice what we did, we started with either pink or yellow, vertical angles or linear pair. We did some of the proof ideas we had from the first unit. We did proofs, and we finalized or finished with one of the 4 in this list. We're going to want to do that every time. Start with pink or yellow, do some math, end with one of the congruency theorems. Okay? Example 7, we're going to do a lot of the work because look, there's nothing in there. But we have a statement answer bank and we have a reason answer bank. We should be able to answer this right away. Based on what is written up here, what is the first statement I should use? The given. It says angle 1 and angle 2 are supplementary. And I'm going to shorten supplementary to SUPP because I ran out of space. Now we know this. What's the reason we can say that first statement? Given. Very good. Okay, fabulous. Yes. Now we need to think about how we can make some relationship between one of those angles, angle 1 and angle 2, and another marked angle on the page. Well, another marked angle on this page is angle 3. How are angle 2 and angle 3 related? They're a linear pair. Linear pair tells me that angle 2 and angle 3 are also supplementary. That's due to the definition of linear pair. Linear pairs add up to 180. Okay, well, if we know these are linear pairs, we now want to make some relationship between angle 3 that we just included in our argument and angle 1. Again, how are angle 3 and angle 1 related? They're corresponding. So we're going to say the following. We're going to say that angle 1 is congruent to angle 3 due to the congruent supplement theorem. And since they're congruent, we can finally conclude that angle P is parallel to angle Q due to that, again, same idea, corresponding angles. So again, I know the math part in the middle was different because we used the transitive property before and I used a different property now, but we started with either vertical or linear, made a relationship there, and finalized with one of the four that can prove parallel lines. So again, it proves that line P is parallel to line Q. So we put the little markings for parallel.
I thought you put the correspondence.
They can kind of go either way. As long as your conclusion is based on the fact that they're corresponding, the order is kind of opinionated, if that makes sense. Okay, last idea here is going to be kind of simple for you guys. It's called the transitive property of parallel lines. Transitive, again, is the one where we cut out the middleman. So it says if two lines are parallel to the same line, then those two lines are parallel to each other. So for example, we're going to say that line P is parallel to line Q. We're also going to say that line Q is parallel to line R. Well, what do you notice now about all three lines in my image, P, Q, and R? What have I put on all of them? I put the same marking to indicate they're parallel. If these two are parallel and these two are parallel, then what do we know about these two? They're also parallel. Again, it kind of sounds like, well, duh, Miss Quigley. If those two lines are parallel and you have a third one that has the same slope, then they're all parallel to each other. Agreed. But this is called the transitive property of parallel lines. And this is going to allow me to then take my vocabulary words from today and apply them to an even bigger system of parallel lines. How many parallel lines do I probably have here in this image? Visually, it looks like P, Q, and R are parallel. But we make sure that in the given, it tells me that they're parallel. It says that line P is parallel to line Q, and line Q is parallel to line R. So we've indicated that all of those lines are parallel to each other based on that transitive property. We want to figure out the measurement of angle 8. Okay? If this is 115 degrees, how much is this one? 115. Why? They're congruent because they're corresponding. They're in the same spot. Well, if this is 115, what's this one? 115 again, because again, they are corresponding and that means that they are congruent. Okay. Remember, our goal was to figure out angle 8. How is 8 related to this 115 degrees that I just filled in? I noticed they make a straight line. What is that called when they make a straight line? It does equal 180, but it's called, the pink, a linear pair. So here's what we know. We know that they should add up to 180. So if I was going to find angle 8, I would just simply do 180 minus 115. Which, if you believe me, is 65 degrees. The reason we're able to do this is because of corresponding angles and linear pair. We were able to write that 115 over and over again because they're all corresponding in this system of parallel lines. Then we took that 115, we're like, great, well, it's a linear pair with angle 8. So angle 8 just has to be what adds up to 180, which is 65. Okay, what if we were using the same system and I ask you for the measurement of angle 9? I know y'all's is like in the center of the page. Again, mine kind of moved over. You have enough room to write it right there. But if I'm asking you for the measure of angle 9, how is 9 related to the answer that we just found? What are these called? Vertical angles. And what do we know about vertical angles? Are they supplementary or congruent?
Supplementary.
Ooh, let's look at our paper. Look at your colored paper. I'm using yellow for vertical angles. That's on purpose. Next to where it says vertical angles on your little coloring sheet, what does it say? Does it say equal or equal 180? Equal, which means they're congruent. So what is the measurement of angle 9? 65 degrees. Very good. Again, this is because it is a vertical angle to angle 8. So they have to be congruent. They have to be the same number. So again, I really, really suggest keeping that coloring page out and used, and please do not lose it, because it's going to really, really help you when it comes to all this vocabulary, because it's all kind of confusing and floating in the air right now.